In previous tutorial, we solved a problem of linear regression where we predicted salary with the help of year of experience, and we also came up with a line which indicated a linear relationship between salary and year of experience. So to understand how a linear regression works, we need to understand what is a linear relationship. Let's go back to our school days and solve simple problems. Let's say you go to market to buy mangoes. You take a paper and pen and you jot down few values for quantities and their corresponding price. So we make a table, and in the table we have quantity and we have price in dollars. Let's call this as X and let's call this as Y. And let's jot down few values. For one quantity the price is 1.5, for 2 the price is 3, for 3 the price is 4.5, and so on. And so for the X value the price is 5. From this we can find that it is very easy to calculate the relationship between the price of the mangoes and the quantity, and it comes something like this: Y is equal to 1.5x. In this, Y, which is also the price, is called dependent variable. X, which is also the quantity on which the price depends, is called independent variable. This value is called slope. Now let's also visualize the relationship between them with the help of graph. So we will draw a graph, x-axis and y-axis. On x-axis we can take the quantity and on y-axis we can take the price. So price starts from 1.5, 3 and then 4.5. Let's jot down these points. For 0 we have 0. For one quantity the value of price is 1.5. For 2 quantity the value of price is 3. And for 3 quantity of mangoes the price is 4.5. We can draw a line between these points. With the help of this visualization, we realize that all the points lie on the line, and that is why we call it linear. And with the help of this line we can calculate the price of any quantity of mango. Now this slope, which is 1.5, indicate with the help of M, is also called the rate of change of price with respect to quantity. For any two values we can calculate the slope, something like this: delta y upon delta x. So if we take these two quantities, we have 3 minus 1.5 divided by 2 minus 1, which also gives us 1.5. So slope is the rate of change of dependent variable with respect to independent variable. Now let's take another variation in this problem. So this time you go to supermarket, but not by walking, but with the help of car, and so you have to pay $1 to parking. And again you jot down, but this time the quantity is, for each quantity you have to pay additional plus 2 price. And this time the equation changes to y is equal to 1.5x plus 2. We have one additional constant term over here, which is parking in this case, and we call it intercept. And the remaining terms remain same, slope. Now the difference, if we visualize the relationship between x and y again, we will find that the line starts from 2 for the 0 value of x, right, with respect to quantity. If the quantity is even 0, we are paying the parking fees, and so the price value will start from 2, and then we can add 1.5 on the top of that for each quantity, and that becomes 3.55. And if we again jot the line between the quantities, we will find the line something like that. which is parallel to the original line where we didn't have to pay the parking because the slope is same. But the real life is not so simple. You may not get the direct relationship between the quantity of mangoes and the price. Let's jot down what it may look like in real life. Quantity, price, right? And we may have this kind of relationship, something which indicates that price increases with the quantity, but it is all the points may not line on a single one line. So what do? If we have to predict the price of certain quantity of mangoes, we try to draw a line which accommodates most of the point, and let's call it as a best fit line, and we keep room for errors. But the line which we draw should be such that the error between the actual value, the real value of the mango for a given quantity, and the predicted value, the value which we are predicting with the help of the line which we are drawing, which we are giving a relation y is equal to mx plus c. This is the predicted value, and let's say the real value is y. The error should be minimum for a given quantity. In our previous tutorial, we were given a problem where we had to predict salary or dependent variable based on years of experience, which is independent variable. But when we plotted the line between salary and years of experience, we could see that all the points cannot be accommodated on a single line, yet the salary increases with the years of experience. Linear regression came up with the best fit line, something like this. In best fit line, it came up with the relationship y is equal to mx plus c, where it gave us best m and best c, which is best slope and best intercept, and x is independent variable and y is dependent. Now this line, as we can see, has room of errors between the actual value and the predicted value. We also came up with different metrics to indicate the error between real and actual and predicted values. How linear regression works, how it came up with this line. It could have come up with any line possible. There are infinite number of possible slopes or possible intercept which this line, the linear regression, could have come up with. But why this line? And this we will be answering with the help of gradient descent algorithm, on the basis of which linear regression works. We will look into very layman terms, and yet we have to touch upon some part of maths to understand this. To explain this, I have taken a very beautifully explained blog to keep the gradient descent as simple as possible. We need to understand it as it is a fundamental for machine learning, and yet we do not want to dive deep into math that much. So I'll try to keep it as simple as possible with the help of this blog. So let's dive into gradient descent algorithm. Let's say we are given any random set of data where there are two variables, one is dependent and the other is independent variable. Let's say we have been given 3 points, 2, 3, 4, and we are given the values of the dependent variable. This can be any variable. We can take example of x as the study hours and y as the score of a student out of 20. So how do we determine the relationship between x and y? And let's say we have to come up with a linear relationship. Y is equal to mx plus c, which gives certain y, and then we find the delta between the predicted y and the actual y, and we say that the error is minimum. Let's see the example. First of all, I'll just slightly update this relationship with the naming conventions. So we are writing y is equal to wx plus b. Now here the slope w is called weight and b is called the bias. X is also called the feature and Y is called the target variable. So if it is a study score of student and this is ours, let's come back to the point where we have to come up with the relationship between Y and X. We are given a random set of data and we have to come up with some Y is equal to WXB. Let's say you don't have any help possible, so you start on your own and you start with any random values. What you will do? You will choose some simple value. Let's say W is equal to 1 and B is equal to 1. For X is equal to 2, this point, right? We will predict the value. Please note that the predicted value is marked with Y hat, okay? Because we have an actual value to indicate with the help of Y. We have Y hat is equal to 1 times 2 plus 1, which is equal to 3. If I draw a table, if I update this table with predicted value, I'll see the difference between the predicted value, which is Y hat, and the actual value Y is quite far. And I intuitively decide that these are not the right values to come up with a linear equation. But we cannot go on and keep on inputting different values of W and B on the basis of intuition. We need something, and that is called machine learning. And that is where machine learning model is coming into picture. So let's see the primary steps how ML model, and in this case linear regression, finds parameter. Parameters are W and B. And why they are called parameters? Because they are deciding the essential characteristics between the independent variable and its predicted value, which is Y hat. As a first step, initialize parameters. Let's say we give the value W is equal to 0 and B is equal to 0. And we replace the value of X as 2, 3, 4 and we come up with the predicted values. Let's call that Y hat. So with W and B as 0, for any value of X, Y hat is always gonna be 0. And then we see the error between the predicted value, Y hat, and the actual value. And let's call it difference or error. And we can define error as Y hat minus Y, predicted value minus actual value. From simple calculation, we know that these values are like this. For error here, we are not concerned with whether it was above the actual value or whether it was below the actual value. We are only concerned with the magnitude. And to come up with the magnitude, we square error. And so we can say Y hat minus Y whole square. And again, from simple calculation, we know that 11 square is 121 and so on. And 17 square is 289. We call this step 2 to calculate all these values of squared error. Calculate squared error for each value. Now let's go to step 3. In this step 3, what we have to do, we have to average all squared errors. And to find the average of all the squared errors to the average we normally do, that is sum up all the squared errors divided by count of errors, which is equal to the count of the data points. We can also indicate this with the help of term called mean squared error, and eventually the formula which we can see is Y hat minus Y whole square, which is summed up for all the data points lying from I is equal to 1 to, let's say, m number of data points, and here m is 3. And to find the mean, this is sum, and to find the mean we divide it with the number of data points. So this is mean squared error. Here summation sign indicates the sum of all the values. Now in step 3, we will also talk about something called cost function. So we have chosen our matrix of error, which is mean squared error. This cost function is indicated by J, and cost function is given as 1 by 2 times of whatever error we have chosen over here, which is MSE, and we will replace it with MSE over here. This is also called loss function or cost function. To come up with the cost function, why we are dividing it by 2, let's keep it simple, and that is for the purpose of calculation. For now, let's calculate the cost function of the given values. And we saw that these are the values of the squared errors. So we will sum up all these values and divide them by 3. So we can say j is equal to 1 by 2 times into 1 by m. So m is 3 here, and we will sum up all the values, which were 121 plus 196 plus 289, and it comes as 101. So with w is equal to 0 and b is equal to 0, cost function j is coming as this. Now we have to again look at these data points. W and b, which is the value of parameters which we have chosen, is deciding the error and hence the cost function. And what is the final aim of machine learning is to come up with a linear relationship where it gives us with a w and b such that the difference, this cost function which we are arriving at, which is the sum of the squared errors and this formula, it needs to be minimum as close to 0, so that when we predict a value for a given data point, it should be as close to actual value. Smaller the value of cost function j, the more accurate is the model. How cost function can be done minimum, that is where the role of gradient descent algorithm is coming into picture. As part of next step, let's call it step 4, what we need to come up with is minimize the cost function by finding best value of w and b. Correct? That's what the aim of this step is. So let's draw a curve between w and j. We can come again with a visualization. So if it is our cost function j, and here we have w and here we have b, we can plot the value of j for different values of w and b, and that will be a kind of 3D curve which you will get. So we will keep it simple. For now we will remove b from the picture for the sake of visualization only, and we will plot the graph between cost function and the value of the parameter. What does that mean? We will take different values of parameter w, and then we will see for what value of w when is the cost function coming near to 0 or coming minimum. To draw this curve, let's see the relationship between j and w. Again, j is equal to 1 upon 2m sum of I is equal to 1 to m y hat minus y whole square, and we know that y hat is equal to wx plus b. J is equal to 1 upon 2m sum of I is equal to 1 to m wx plus b minus y whole square. Correct? And we can also indicate that because it is this x is referring to individual record and y is referring to individual values, we can mark on the top of them I to indicate individual values. So we see that j is related to squared power of w. If we draw a graph between j and w, let's draw it here. Let's start w is equal to 0 from here. We already saw that value of j for w is equal to 0. Now since j is related to the squared power of w, we can draw a parabola. These values. So let's say this is the graph. Okay. And we know that j is minimum at this point. And we also know that right now that at w is equal to 0, j came out to be 101. We have to arrive at this value of j, and we don't know what is the value of w at this point. So we have to gradually arrive at this point. The analogy which is famous all over the internet is like this, that suppose you are a blind person and you have to get down a mountain. You will take a step one by one, right? And then you will see whether you have reached the bottom or not. And then you can go in any direction right? And you can take any number of steps. And similarly, this algorithm can take any number of steps. This is a step and it can go in any direction. Direction can be this as well. Now when we talk about this, let's talk about little bit about slope, which we might be aware from our school days. So what is slope? So let's say we have lines, right? We have 3 lines. One is going in this direction, one is going in this direction, and one is parallel. What we learned previously in this tutorial is slope, which we are indicating with W over here, and earlier we indicated with M also, is the rate of change of variable y with respect to x. Now if y increases with the increasing value of x, we get this kind of line. If it decreases with the increasing value of x, we get this line. And if it remains constant with whatever value of x, we get this line. In this case, we know that the slope is positive in nature, because we have, if we see delta y upon delta x, right, change in y with respect to x, it is positive. Similarly, here in this case, slope is negative in nature, for we know that y is decreasing with increasing value of x. And in this case, y remains constant, so delta y is equal to 0, and hence w is equal to 0, or slope is 0, right? So we have 3 types of slope. Now let's come back to our original parabola graph. We have 2 things over here. One is the size of the steps and the direction. Size of the steps, how much jump we make towards the value we want, or towards to achieve minimum cost function, size of the step. This is also called learning rate. And then we have the direction. Learning rate is also indicated by alpha. And then we have the direction in which we are going, whether we are going in this downward direction or in upward direction. Eventually, every time we jump, we calculate the new parameter. So we started with the parameter w equal to 0, and we jumped and we calculated the new parameter value. In that case, we are looking w updated, the one which is here. Let's say we jumped over here and we want to find this w updated, is equal to whatever w we have started with, let's say w current, right, minus alpha times rate of change of cost function with respect to w. Let's make it more clear now. I'm sure I have introduced one more thing over here, which is derivative of cost function with respect to w, and don't worry, I'll be talking about it in some time. So let's draw the curve again. So we have this curve between j and w. W is the slope, right, or the weight associated with a feature, and we are deciding the best value of w to come up with the best value of cost function, or minimum value of cost function, to come up with our best linear relationship, right? And we also know that this value is the minimum, where the cost function is minimum. And we also know right now that we started at, let's say, w is equal to 0 and cost function was 101 in that case. And now what we are trying to do, we are trying to reach the minimum value of cost function. And we have indicated that the new value of cost function, let's say this learning rate is alpha, w updated is equal to w current minus alpha times of d of j with respect to d of w. Now what is this new parameter d of j with respect to d of w? Believe me, we need to understand a little bit about it. I'll head to a very simple website called Math is Fun to make you understand about this. Let's talk about derivative with the help of Math is Fun website, which is an awesome website about maths, and I'm directly going to this. Let's get a little bit introduced to derivative. I will definitely not be going dive into deep, but let's see. So we know from linear equation that slope is the rate of change of y with respect to x. And in case we have this kind of relationship between y and x, we can find the average slope between 2 points simply by delta y upon delta x. But let's say if we have to find the slope at particular point, like we have to find in case of relationship between w and j, which we have seen at any point, we need to know the slope. How do we do that? Now, for any point, we cannot say that because for any point slope is 0 by 0 does not make any sense. What we do? To find a slope at particular point, we use a very small difference between 2 points. And that we do with the help of derivative. The slope of a point where the delta y tends to become 0 is called the derivative. You can go into detail where they have shared an example to find the derivative of a function called x square. Let's move further to something called partial derivative, which we are actually using. If I talk about partial derivative is when the dependency of this target variable is on more than 2 variables. In that case, we have to find the rate of change with respect to each variable. Like in our case, cost function is dependent on w, which is a weight, and bias b. So in that case, we need to find a slope, that is rate of change of target variable with respect to y and j. Now there are certain formulas, and I'll not dive into the calculation. What I'll do, I'll just take the help from this blog which I mentioned. We got introduced to this partial derivative of dj by dw. So what does that eventually mean? We saw that to arrive at the minimum cost function, we are trying different values of w. Let's say we tried this value, w is equal to 0, and then we took a jump and we tried the different value of w. And this jump was called learning rate alpha, and this is the slope. Now slope, what is the slope is at any point, what is the slope? This new value of updated parameter w is given by value of current value of w minus alpha, which is learning rate, into dj by dw. So dj by dw is nothing but the partial derivative of cost function with respect to w. Similarly, we will see dj by db also, which will be partial derivative of cost function j with respect to b. So what are these values of dj and dw calculated as? Now we have to keep in mind this equation for now, and if you want to dive in deep, we have to you can explore more how we are arriving at this equation, but let's keep it simple now. dj by dw, which is the rate of change of cost function with respect to weight of a feature, is given by this number of observation, then summing up what we did, y hat minus actual value into x, okay, independent variable. Similarly, dj upon db, this is dj upon db, is given by 1 upon m, summation of I is equal to 1 to m predicted value minus actual value. Let's fill the table with these values. Now we have to calculate the new values of w. right? We have this formula in place that W updated is equal to W current minus alpha times of dj dw. Similarly, we can also find the new value. So on the basis of this equation, now we have some constant learning rate, let's say 0.01, and we have also found djw. We can find the new updated value and then we can again input to find the predicted value. Let's see how. So again we will draw a table. X, Y, W, B, Wx. To find new W, we have to find Wx plus minus Y into X, and then we have to find dj by dw on the basis of that formula. So we have values of 2, 3, 4, 11, 14, 17. W and B we have chosen as 0. So these are current values of W and B. And then this, if we calculate with the help of inputting value of X and B, so we get minus 22, minus 42 and minus 68, right? And if we calculate these values, which is given by the sum of these values, right? Sum of these values divided by 3, we will come up with minus 22, minus 42, minus sum of these values divided by the number of observations, right? We arrive at minus 44. Now we have to identify the new value of W. So W updated is equal to W current, which is 0, and we have taken learning rate as 0.01. That's alpha is equal to 0.01 into minus 44 is the value of dj by dw, rate of change of cost function with respect to W. And we get the new value of W updated, which is equal to 0.44. Alright. Similarly, we calculate the value of B, updated B, right? By again giving X, Y, W, B and dj by dB, right? It was Wx plus B minus Y, sum divided by 1 by M. B updated equal to B current minus alpha into dj by dB, and we arrive at the new value of B as 0.14. Alright. Now this is the first iteration, and with the help of first iteration we arrived at some value of W from W equal to 0 to W is equal to 0.44. Let me make it more clear. So after this first iteration, what is happening? We have a graph between W and J. We started with the W equal to 0. Our cost function value was 101 at that point, right? And we have to reach here. We took the learning rate as 0.01, and then we arrived at the value of W, new value of W, which was 0.44, right? And then we find the cost function at this point. Again, how? By inputting the value of y hat in Wx plus B at this time, and similarly we also found the value of B. So this is 0.44 and this is 0.14, and then again we do y hat minus y and then sum up, and then we came up with the cost function. So new cost function, let's say, comes at this point as let's say 80. So it has reduced, but still it is not near to 0. This whole iteration of finding new W and new B, this was iteration 1, and this algorithm was called gradient descent. Now we realize that we have not still reached to the minimal value of cost function, and we need to travel more, right? We need to travel more towards this side, and we need to perform many iterations to arrive at minimal value, which is near to 0. If you see, we decided the this alpha is equal to 0.01, which was the learning rate, is also playing very important factor. Had we taken if we take very small step over here, right? Instead of alpha equal to 0.01, we take alpha equal to, that's 0.001. We will reach to our intended destination very late, right? If we take very small steps instead of these. But if we take very long steps, if the learning rate is, let's say, 0.1 or 1, right, the steps to reach the destination become longer, and instead of that we might reach over here and realize that we have not reached the intended destination, and then we can go back forth, and this will again lead to back and forth thing. So this learning rate value needs to be optimum.